Hello everyone, this is a lecture to introduce torque. Now this is definitely the most difficult topic in the course, but also the most important. So we need to define torque, we need to see how you're going to use it to calculate forces within your body. So we're now going to be looking at what kind of forces your muscles exert on segments of your body. So we know about forces already. So we've looked at external forces, looked at the force of gravity, acts on everything. We've looked at normal forces. If you're standing on a surface, there's an upward normal force on you. We've looked at friction forces, whether it's a static friction force when things do not move, or whether it's a sliding friction force. So now when we talk about torque, we're only really going to be looking at the external force of gravity exerting torques on your body. And then we'll have muscle forces exerting also torques on your body. And we'll see how these things balance and how we're going to use that to calculate muscle forces. So let's just think about the force of gravity now. So when I stand here like this, the force of gravity is just straight down through my feet, from my center of mass, and it is not exerting a torque on my body right now. But it definitely does exert torques on your body. So think about what it means to walk. So I'm standing here, just imagine the force of gravity straight down. If I lean over past my toes, now there's a torque from the force of gravity on my body. And what happens? It causes me to rotate. And I have to catch myself so I don't fall on my face. Okay, that is actually how you walk. You are simply falling over and catching yourself. So force of gravity moves past my toes, I'm going to fall, and I catch myself. Now, the reason that my feet don't go out from under me and I just go flat on my stomach is because friction at my feet is allowing my feet to stay stationary while my body rotates about my feet. Okay, so what is torque? Torque is the measure of how well a force can cause rotation. Now, the reason it's so important is because now let's just go to parts of your body. Everything you do is a rotation. Think about it. You move your arm, you're rotating about your elbow. You move your arm like this, you're rotating about your shoulder. Tip your head, you're rotating about this joint back here. Move your hips like this, you're rotating about your hips, your knees. Everything in your body is a rotation. How can you possibly move a segment without, to try to move this part of my body? Now that's not a rotation. It's rotating in my shoulder. My forearm's not rotating, but that's kind of a goofy motion. So almost everything we do is a rotation. So what we want to know is, what are the forces causing the rotation? How do we calculate the torque? And how are we going to use that to get muscle forces? Now, the best way to think about this, it's all geometry. So I think the difficulty people are having are, you're having a hard time calculating what is called the lever arm, okay? So the lever arm is the distance, let me hold my hand out there. The lever arm is the distance from the axis of rotation. So here, my axis of rotation is my elbow. Now, the lever arm is not the distance from my elbow to my hand. That is that's just the distance from my elbow to my hand. So the lever arm is the distance from my elbow to that black string hanging down there. So watch what happens from my elbow to the black string. That's as far away as I can get it. But look when I move my arm up, look at that black string. It's getting closer, it's getting closer, it's getting closer, it's getting closer to my elbow. The lever arm is this little distance right here. And look what happens when it's right over my elbow. Zero lever arm. And that's why it's so easy to hold this like this, because there is no torque from this weight about my elbow. But as soon as I start moving this black line away from my elbow, the lever arm here is getting bigger, it's getting bigger, it's getting bigger, it's getting bigger. And that is by far the hardest position. That's the most torque. Now the force never changed. The force is from this weight hanging down. So however heavy that weight is, that's it. Force is fixed. The line of action of the force, that's this black line. That's the line of action. Always hangs vertically down. Weights hang vertically down. So, but the lever arm is from here to there. And look how it's getting smaller, smaller, smaller. So what you have to calculate, the torque, is the product of those two things. It's easy to calculate the force. mg is the force. It's easy, you're told the distance usually from your elbow to your hand as fixed. You can't change how long your forearm is. The tricky thing is the triangle to get the lever arm. Look at that triangle, it's changing, but it's just geometry. Okay, and it will be a right angled triangle because look, the lever arm is perpendicular, so that'll always be a right angle. The arm, the forearm is the hypotenuse. And given whatever angle, whether you're given the angle up here or you're given the angle down here at your elbow, it doesn't matter. You guys know trigonometry, sine, cosine, tangent, and you're going to have to calculate that lever arm. Multiply them together, and that's torque. Now, you can have torque about different axes. That was my elbow, but what about torque about my shoulder? Okay, now the distance, axis of rotation, very important you define axis of rotation. It's always a joint. In your body, it's always a joint. That is the definition of a joint, axis of rotation. Okay, so as I lift my arm up like this, now that's the biggest distance I can get that black line from my shoulder. That's the biggest torque. That's the hardest, by far the hardest to hold it there. Look what happens as I lower my hand. The black line's getting closer to my shoulder. It's getting closer to my shoulder, getting closer. It's the distance from my body here over to that black line. Look, it's getting smaller. It's getting smaller. It's getting smaller. It's getting smaller. There is no distance now. There's no torque from this weight. The weight's just as heavy, but there's no torque about my shoulder because this from my shoulder, there's no perpendicular distance. There's no distance out there. Okay, now the distance is getting bigger. So it's between my hip and my hands. Between my hip and my hands, hip and my hands. And look how this distance is getting bigger and bigger and bigger. Your job is simply to calculate that distance given the geometry, multiply by this force, boom, you got the torque. Now, those torques are external. This is an external weight to my body. Okay, this is from the force of gravity. So how is it now that my body can actually lift it? This is where internal forces come in. So if I'm like this, and I want to move my hand up like this, what force in your body is doing that? Well, first of all, is the application of the force on this side of my elbow or on this side of my elbow? If I want to move my forearm, what side do I have to have some force pulling? Well, clearly it has to pull on my forearm. So the attachment of your bicep muscle to get your forearm to move up is on that side of your elbow. It's over here. Now, it's not very far over here, but it has to be over here and attached to the bone on that side of the elbow. Now, it's very close. And so when you do the perpendicular distance from that muscle attachment to the axis of rotation, which is still the elbow, it's a very small distance, tiny, tiny distance, which means the torque that the bicep muscle can exert, because it's the product of force times distance, it has to be the torque equal to the torque from the weight. It's a big torque. But with a tiny lever arm, it means your muscle force is huge. The force in your bicep muscle is much, much, much bigger than the force of gravity of the weight that you're holding. And our bodies have terrible mechanical advantage in that sense. We have to apply huge muscle forces in order to get our forearm to rotate because that point of attachment is so close to the joint. And we can't do anything about that. We can't have muscles. Like, wouldn't it be great if our bicep muscle attached way out here and then you pull here? Well, that's great. That would be exert a big torque because it has a big lever arm. But we can't have muscles coming out of our body here. They have to come out all around the joint. So they're very close to the joint. Okay, so and then now what if I'm doing this? What muscle's doing that? So it's the deltoid up here. And where is it attached relative to my shoulder to get this to move? Well, it has to be attached on that side of the joint because that's the part that's moving. Okay, so the lever arm, which would be right in here close to your shoulder, would be tiny. The muscle force, which has to be along your body and sort of up at an angle like this, is huge. So that requires a huge amount of force, much bigger than the force which is due to the weight of my arm. Okay, so it's all about calculating these lever arms from the geometry. That's the only thing that's going to trip you up is where's the triangle? How do I get that perpendicular distance? And it changes depending on where your arm is. So it's very important that you know where your arm is to get that distance. Okay, and so we'll be doing biceps, we'll be doing arms, triceps. So if you're this way, once again, the elbow joint is the axis of rotation. And then if I'm hanging something up here like this, the distance between, I can't really see that, can you? Yeah, the distance between that line and my elbow joint. Let's see how it changes as I move up like this. You're gonna have to calculate how far away is that line from my elbow. And that line is moving as I move my hand up and down. Also, we will do the quads, so like leg extensions here. Okay, so if I want to lift my leg, where does the attachment have to be? It has to be on that side. It has to be over here somewhere to lift my leg here like this. Okay, so I mean, this does kind of go around your knee and stuff. But so given where the attachment is and how the ligaments and tendons and stuff work, you'll be able to calculate the torque due to your quads. Now, counteracting that is the torque, whatever's on your foot. I don't think I can lift this. Maybe I can with my foot. Okay, so the distance from the black line to my knee, look how far away it is now. Huge lever arm. Now it's getting closer. The black line is getting closer. The black line is getting closer. Hanging straight down. There's no torque now from that weight about my knee. It's hanging straight down. That's easy. But now getting further, getting further, getting further, getting further, and that's the furthest that black line can be. Okay, so calculating torques, it's all about the diagrams and calculating those distances. So I'll help you with that in the tutorial later today.